linear equations. And with this problem, we're going to start with graphing two ordered pairs, and then from there we're going to create a linear equation in slope-intercept form. So the first thing I'm going to do, so consider the points -2, 4 and -6, 5. So as a reminder, when we're graphing, we need ordered pairs. So we need an x and a y, and this one's going to be x and y. So as a reminder, this is the x and this is the y-axis. So I'm going to zoom this in so we can see a lot better. Okay, so I'm going to go left -2, and I'm going to go up 4, so that's right here. And then I'm going to go -6, 5, so -6, and then 5. Okay, and I'm going to consider the line that passes through those points. So I'm going to try my very best to make a line, and I don't know exactly where it's going to go yet, so I'm not going to continue that yet. All right, so find the slope of the line. So I can find the slope. So the slope means how steep. So slope is steepness. And imagine that my x is time. So I'm just going to talk about it going left to right. So if I'm moving left to right, from the first point, I went down 1, and I went to the right 1, 2, 3, 4. I went to the right 4. So that's one way to do it if you're graphing it. But if I'm not graphing it, I can also find the slope. So what we did was we took the second coordinate and we subtracted the first coordinate, the y value. So the change in y over the change in x. So it's a ratio. How much is my line going up or down over how much is it going to, let's say, the right. So for this one, I'm going to have 5 minus 4. So we're saying this is the second y, this is the first y, this is the second x, and this is the first x. And if I want to write it out, I could say y2 minus y1 over x2 minus x1. It doesn't matter which one I chose as the first coordinate and the second, but it does matter that if I chose 5 to be my second y value and then 4 is my first, then I also choose the second x value, so -6, so those match up, over, so minus a -2, so those also match up as an ordered pair. Notice also on the bottom when I subtracted, I made sure to subtract the -2, not just -2, because it's not 2, it's -2. So on the bottom, -6 plus 2, so 1 over -4, and that's the same thing as -1/4. You agree? Oh, yeah. So my slope is going to be -1/4, and I also can verify on the graph. All right, so now I want to find the y-intercept. So where does it hit the y-axis? And there's a few different ways to do it, but the way that I'm going to choose to do it, and I could go, let's see if this works. I'm going to go down 1, 1, 2, 3, 4. It's kind of hard to see on my graph, so the slope between any 2 points, or the slope is the same slope between all the other 2 points. All right, she's upset. Thank you, assistant. So the slope between any 2 points is the same wherever I go on my line. So I can't really see where the y-intercept is. So what I'm going to do is I'm going to use point slope form. And what point slope form lets me do is, given a slope, which we have, and given a point, which we have 2 of them, I can figure out what the y-intercept is, and I can also find the slope-intercept form of my line. So it looks like this: y minus y1 equals mx minus x1. And when I have y1 and x1, that means that those are actually going to be replaced. So let me circle. These are being replaced. My slope is being replaced, but this x and y, that's just essentially making a linear equation. That's my function. Those stay. So I'm going to plug in what I've got. So I've got y minus, and we just chose this one, it doesn't matter which one you do, minus 4 equals our slope, -1/4, x minus, and then we chose this to be our first ordered pair, so minus a -2. Okay, so I don't have a lot of room, so I'm going to bring this down here, but know that I'm going to answer part D also in C. We'll just box each of them.